HTTPS. You may, if you run doing the HTTPS, then drop the S and then try it. So if I, this is going to be longer. So now, never mind. It's going to be a long one. So cbyte, what it is it's going to conduct a database in its package, and it's going to so it downloaded it and then it installed it. But then the library, this one is probably going to be long for you guys. I hope it's not going to be long for mine. It's going to, yeah, maybe long because it's going to try to install or import dependencies, and I've already imported all those dependencies. So this is a bit of time. And at some point, there may be an option and ask if you want to update some of these dependencies, and you can choose from there what you want to do. It stops you and it asks. I don't know if I have that still in my memory. I don't. So. I'll get back. Hi, Dr.
Can you hear me?
Yes. Okay. Okay. I'm going to assume it's going for most of you for a second. Waiting. I'll show a website. So this is the Bioconductor website, and it's going to be your source for looking up packages. So if you want to do one type of analysis, you can search for it, and it will pop up with different packages within this Bioconductor repository. You download and install them and show you all them, and it also has I'm trying to see if I find exactly. It will have document associated with each one of them. So this is the one. So it's going to allow. It tells you a little bit about it. It tells you how to install it. Pull up the documentation within R. Gives you an image short read and a reference manual. And production also comes with some example code. So this is kind of like a little mini tutorial. It's going to tell you kind of what you can do and give you examples. You're also going to have the reference manual, which will be the complete. It'll tell you every single method that it comes with the package and how to use them and what exactly they do. Any kind of publications that are associated with it. And again, I don't know if any of you caught it, but this is open source. So if you develop your own R code for analyzing any kind of biological data, you can submit here, and then it will be available to the world of researchers. That's my that everyone has downloaded it. But I assume that you have. Dr. Valfar?
Yes.
Could you use your mic?
Yes, ma'am. Sorry.
Thank you. You're typing.
I'm not typing.
Somebody is. You. Okay. Within this library, there is a function called read FASTQ. And you guys a small FASTQ file. I hope most of you got it. If you have, then you want to give it the correct location on your computer to where it's sitting. This is sitting. I do this. This is where our funny. Well, it may have already gotten funny. But this is a little here. FQ, which is what I called my FASTQ, comes in as what's called a formal class short read. And the properties that it has is quite a bit. It's noted by an @ sign, so that's how you would access it. So a lot of stuff in it, which some of it is going to be really useful, others of it is used before, useful it is, but we're with this. So this is another structure. Inside of it, there's data frames. Inside of it, there's lists, but it's kind of a it's a class. It's an object. You can access the inside. So again, you can also print out. So if the it's going to give me a little shorter description. It's going to tell me what kind of data type it is, which is a short review. And these have 5 different sequences in here. My small FASTQ file only has 5 sequences, and the width is how many nucleotides per read size, and it was 76. Now, if I isolate and I want to look at my reads, there's this command sread, and I send it to my FASTQ object and my data points. So, of course, if you have something that has more than 5, which you most likely will, this could get this a ton. To limit it. Oh, quick. This is another way to access it. If you just it with the @ sign, sread, same thing. That's 2 different ways to access it. To limit the number of reads that you get back, you can use this command called head. And in the Linux workshop, this is the same kind of concept as if you're in a Linux terminal. It's to give you the top and whatever you specify number of lines within your file. So here I want to give it a read and the top 3 entries. Here I get my top 3. So this is useful to have larger data sets. And it's not just for FASTQ data, it's for any kind of data. We could have used it, for instance, on our iris data. So if we just wanted to get the first, I could spell iris, this would work. If I want the first 5, I could do that. Iris data set too. Another thing with FASTQ data is the quality, and this is just how reliable each one of those nucleotides calls are. So if I have quality, then I'll get my quality score. For those of you who are familiar with FASTQ, you know what I'm talking about. For those of you who aren't, I hope I got enough detail. So again, this is just how to limit to access it differently and how to limit your the results that come through the screen. So this encoding is an ASCII encoding. So it's not necessarily that A is or it means that it's like the best score you can get. And then you see that there's like @ signs and equal and question marks. Each of these have its own score. To access it, you can use this encoding. So encode, and then you send in your quality. And so in general, anything greater than 30. So if we go back up to our, just grab this, C corresponds to a score of 4. Anything than 30 is going to mean that a probability of the incorrect base call is 1 in 1,000. So that's a pretty good, but you want to limit it to something even higher, and you want ones that are low. So for instance, equal here corresponds to 28. So you would not want to, you may exclude either just the nucleotide associated with this or that entire sequence. Correct. The best. I've seen that in data though. Mostly, it kind of is right around in the capital letters. So, at least what I've seen. Okay. So, again, table function, look at, so now we have more than one read, can kind of think that the table function may give us a little bit more information. All of my sequences are unique, so I'm just going to get that each of these sequences occurs once. So it's not what you can imagine with a bigger data set and with simplification. You get, you may figure out a little bit more about your data, about which sequence occur more frequently. Go over which I have time for, but it looks like I may. You can distance. Wait 1 second. Let me. So you can find the distance a given reference sequence and the rest of your sequences, and this is useful if you want to find a certain sequence, or small sequence like an adapter sequence, which is big noise in your data you want to find and you want to eliminate. You do that the following way. Here, if I have my tables, FQ is each of my sequences, many times that they occur. So I'm in the top there. Of course, all occur once. So give me all of them. So since wanted, so we can just choose any of them to start. I'm going to choose. I wasn't going to go over this, but I will. This names function here, if I run it, is just going to give me the sequences again, and it's going to give me it in the form of a list, I think. Yeah. Oh no, it's a vector. So it gives you in the form of a vector. Something that you can do in R. So this is, instead of saving that into another variable, which you very well could, and then querying it the way that we're used to with these brackets, you can actually query the results, so a temp results file. So if you're worried about using space, so if this result is going to take up like a gigabyte of space, you really maybe want to save it in memory. You just want to create it in temporary memory and get a certain sequence out of it, but not the whole thing. So you can. So this is going to give me that second entry only, which it did. And I'm going to use sequence. I'm going to pretend that that's something that we want to find. And what I can do, I can use this function called SR distance, and I give it my reads. So this is my reads from my FASTQ, and give it that sequence that I think is important for whatever reason. Then I get something like that. Now, this is what you would think. So basically it tells you how many of the base are the same. So kind of a percentage of like sequence similarity. And of course, one. So this compares all 5 of the sequences that we have in FASTQ. Means that everything is the same. Since that 43 are different, 42 are different sequence. However, what's strange, and I think what's happening, I was looking at this earlier this morning. I chose the second sequence, and you would think it would do it in the order of the sequences. So this one should be my 0. But I think either it prints backwards, where this is the first entry, this is the second entry, so it's doing its calculations, but saving it kind of in a backwards fashion, or for some reason it's randomly shuffling them. But what you can do, so here, okay, it just gave me the same thing. So here, I found here, and I can do a table. I can find out how many, so if you saw before, I had 2 that were, did I have 2 that didn't have 2? I thought I had 2 that were 3. Oh, okay. Oh. Well, that's for some reason. Okay. Reasonable results. So here I can see that I have exactly matches. I have one sequence that exactly matches, and I have others that, so I have one that is, 42, I have one that's 43, and this is going to be subject matter expertise of how similar do sequences need to be such that, they're, if I was to use a smaller sequence, so an adapter sequence is maybe 10 nucleotides, then I go and I could find if any of them are, for instance, common, then I could grab those out and I could say, I could eliminate the adapters off of it, which is basically, I can get rid of the contamination on those sequences. So that's all I have to show for today. Tomorrow, of course, we're going to back up with this FASTQ data, and we're going to dive into some genetic as well as gene counts and different expressions. But just before we go, about either the biological analyses or the PCA and thing that we went over to begin with. Okay. So if you have questions that you think later on and you want to send them to me, or you want to send them to me privately, you can just send me an email. I will post. I'll send our code around to you soon. And again, if you have any requests for tomorrow, let me know, and I'll make sure to fit that into the workflow. So thank you very much. I'll see you guys tomorrow.